Okay. Welcome back. We have a Q&A right now, and on our Q&A panel, we have Emmanuel, Wally, Nick, Daniel, Jaime, Vicki, Manish, and Verónica. Wally, you're muted. Sorry. You know, housekeeping stuff. Anyways, and standing in place for Ed Huang would be Arthur. It's not like we can replace each one of us. And anyways, that was a bad joke. So the way we're going to do this is I'm going to ask individual questions, and then I'm going to ask the group questions, and then we'll take turns between individual and group. The group, please feel free, panelists, please feel free to actually butt in when you have good answers, because this is, after all, designed as a panel. And the order of questions is random based on a spreadsheet, so you can just blame Google Sheets random function. All right. So to start off with, Daniel, are the functions that you showed on your slides, they're pretty branch free, I noticed. Easter eggs for the conference?
I didn't get the question. Mistakes?
No. Are they Easter eggs? Because they're actually pretty. You don't actually normally see branch-free functions being written in the wild, right? So
right. Well, yeah. But when you want to go fast, it's definitely a concern. So you definitely do want to be as branch-free as possible, because our processors can retire, upward of 4 instructions per cycle, but only if, and they can only retire useful instructions if there are not too many branch misses. And so you have to be really mindful of your branches, and it's really helpful if you can re-engineer your code to avoid them. And it's often a mistake to believe that they're free. I mean, there can be free if they're easy to predict. But when you're working with stuff like string inputs, they can be a little bit random and very difficult for your processor to predict. What makes this worse is that it can be really difficult to benchmark, because your processor is really clever and it can learn. If you do only short test, it can learn to predict the branches of your short test. So you really need to put your code in the real world to see the negative effects.
Okay, cool. All right. Next one is for the group. So everyone, I'll just go around the panels. And this one's actually a very touchy subject. Concurrency in Go or nominal typing, which one is more appealing or popular for you? Like, which is your favorite feature? Well, Go doesn't actually have nominal typing. I don't know who asked this, but kind of has nominal typing. But yes, concurrency or the interfacing, basically. Like the
interfaces, like Go interfaces.
Duck typing, if you will. There's a name for it. I can't remember the name for it, but yes, structural typing. That's the word I'm looking for. Structural typing. Yeah.
You mean strongly typed language?
No. This is a structural typing. So your interfaces are basically, if anything fulfills the interface, that's the type. So which is your favorite feature? We'll start with Emmanuel.
Mine would absolutely be concurrency. Many languages have suffered from not having really good concurrency libraries. I mean, look through ones that have been used historically. Concurrency is a big pain. It's hard to teach people concurrency. It's hard to get them working right. With Go inbuilt, the Go routines are light, and we have a poller that makes that removes the need to manage threads. And that's still a pain in Java, Python, all these languages. But Go does that great. Thank you.
Arthur?
Yeah, I got concurrency.
Concurrency too?
Yeah, because we can use channels Go routines to make a concurrency system, and it's very easy for a normal programmer to handle high concurrency, right-hand concurrency programs.
Cool. Wally?
Yeah, no, the concurrency, of course. Yeah, I mostly do Python and Ruby, and it has taken more than a decade. And even some ecosystems like Rust, I'm waiting for the proper async.
Yeah.
And God just has it from the beginning, and so that's it was a game changer.
Shame that G event didn't make it to the Python. Anyway, sorry, Nick.
Yeah, I'm going to be boring and agree with everyone else. I did more than 12 years of Perl programming, and concurrency was a big reason why I adopted Go in the first place. The select loop is just fantastic.
Vicki, sorry.
Yeah, I mean, I feel like I can only say concurrency. I also gave a talk about routines, so maybe everybody knows. I do love types, but I think what really makes Go special is definitely the concurrency primitives, and that's what I've come to love.
Cool. Jaime?
Wow, I think I'm going to be the black sheep here. I think, actually, I'm not a big fan of the concurrency. I think it's super easy to use, which is not necessarily a good thing, because sometimes it gets jammed in places where it doesn't really need to. And I've definitely run into situations where I tried to do something cool with concurrency and Go routines, and it actually ends up being slower than just doing it serially. So I'd go for the types, I guess.
Daniel?
Yeah, so I'll be a second black sheep, and I will say that the typing system actually is so great that it made me go back to, when I go back to C. I actually, because it's kind of there a little bit in C in some backward way, it actually makes me maybe an even better C coder or appreciate C more. Whereas I have exactly the same feeling. I think the concurrency model is really easy, but it's really difficult to make it efficient. And that's going to be a struggle because we're not getting these 1,000 core systems that would make really good use of that. So, well, we got to 64, which is pretty good, but it's slow going. And for that reason, Go is really optimized for this really like infinite number of core setting. And it's not really doing so well with respect to performance, I think.
Verónica? I think you're muted, Verónica.
No.
Hi.
Oh, yeah. That's good.
Oh, cool. Sorry, it's Linux. Yeah, so going back to the concurrency team, that doesn't mean that Go is my favorite language for concurrency, but given the question, yeah, I prefer Go concurrency. And it reminds me of early Go conferences and even books where people would say to not use the Go concurrency for the sake of it. That was to avoid a little bit of noise when you really didn't need it and stuff like that. But yeah, in my opinion, if you're not using Go concurrency, then you should be using something else, but that's a whole different question.
That's related to one of the questions that we have here. Okay, Manish, go.
Yeah, so I think Go concurrency, obviously, that's my favorite, and it's also interesting because back when I was working at Google in web search, they actually had implemented lightweight threading on C++. And they would run like thousands of these lightweight threads. And it seems to me there must be some sort of like knowledge transfer there, because when I saw Go's Go routines, I felt like we have that back and we have it now available to masses. And the great thing about that is that the way you think about writing your code itself changes. You no longer have to worry about callbacks. You can just write all of the code in a single, let's say, function or in serial order, and just have tons of Go routines executing the same code. Simplifies the code base, makes it a lot more readable, and lets the language deal with how does it get scheduled and so on and so forth. So I think the ability to avoid callbacks, keeping the code serial, like that, just that itself is a complete sort of mind shift in what Go has been able to achieve.
Blue functions and red functions, right? Sorry for if you guys hear crickets, it's because there are crickets around my house. And there are a lot of it. So sorry for that. The next question is actually for Manish. Are we doing anything, adding an extra layer from our side in case there's some security issues in Gemalloc?
With Gemalloc?
Yep.
Yes, not really. I think we do have, we have wrappers around the calloc and free functions that we are using. And we have some extra instrumentation there, for example, tracking how many bytes we have allocated. So we can see there's a memory leak coming from our programs. That's one. And also because we cannot use Gemalloc's profiler because of the C-Go boundary, we don't really get to see what called that. So we're using runtime.caller in Go to track who is allocating memory and when are they releasing that. So some of those instrumentations like help us do leak detection and then identify the source of the leak. But the good thing is Gemalloc has been around for such a long time, and they have been sort of improving it, and it's been hardened by so many companies that I actually prefer Gemalloc's memory management over Go's memory management, for what it's worth.
Have we tried using perf, by the way? Because I think perf can actually look into if you import the correct dwarf symbols and don't compress the dwarf symbols, perf can actually check out which Go function is actually calling the C functions, I think. I'm not sure. All right, next question is for the group. Recommend a book for Go. We'll start again with backwards, so we'll start with Manish this time.
Recommend a book for Go. I don't actually have any Go book, but I do have a book for the editor. And I feel like that's the book that people should be reading, is whatever editor they're using, just get really good at that editor. As such, I am a Vim guy, so Practical Vim is a really good book.
We were just talking about that earlier. I'm unfortunately using an operating system with lack of a good editor. Anyway, Verónica.
It would be the Go programming language, like by
the Alan Donovan one.
Yeah,
okay.
yeah, definitely. Because I think it's very simple, straight to the point. To be honest, I haven't kept up with a lot of books that on the recent years, but yeah, from the ones like the most famous ones, that is my favorite.
Okay, Vicki.
I am also going to say that I don't have a Go book, but my favorite software book is A Philosophy of Software Design by John Ousterhout. It's not super long and just full of a lot of wisdom.
Cool. Jaime?
Yeah, I don't have a book specifically for Go. I guess mostly I just picked it up on the job and doing examples on tutorials online and messing up a lot. Fixing a lot of race conditions, which is probably why I'm salty on the concurrency. But just doing it a lot, I guess, just getting your hands dirty, and that's how you can pick it
up. Daniel?
So I would say the Go language specification. It's not a book, but
the doc actually, all that stuff is good.
It's pretty good.
Yeah, it's actually very well written, I think.
Yeah, it is. I definitely read that.
And you can hold it in your head, like you said. At one point, I actually did some parsing for the different specifications, different semantics for different languages, and Go's was so small. Amazing.
Like an order of magnitude smaller than Java or C. C++.
Yeah, exactly. C is actually pretty small.
Yes,
the thing is they push everything to UBs. Right? So yeah, what's your book?
I actually I've never read a Go book. When I started, there weren't any. I was glad that Vicki mentioned the philosophy of software design, because that was the only book regarding software I've read recently that I could recommend. So, but I didn't remember the title, so I'm glad you brought it up. But yeah, I will second the spec. The spec is great.
Yep. Wally?
For Go, actually, not the book, but the materials from Dave Cheney, his blog posts, and what Rob Pike has also written, I think, is what I often go to for revisiting techniques on applying to the code. The errors are values, blog posts, all of that could be, in like part of the Go book that we go to. I don't know. The favorite book, I guess, The Little Lisper. It's a fun book.
Good man.
Yeah. Yeah.
Actually, on that note, I remember like there was a talk by Dave Cheney about when he was introducing channels. Sorry, not by Dave Cheney, but by Rob Pike when he was introducing channels, and he talked about how you can build a Lexer using channels, and that code became Lexer in dgraph. Like we kind of got inspiration from there, and we kind of like took a lot of concepts from there, and that was the first Lexer that we wrote in dgraph. And over time, we sort of obviously optimized it and changed it slightly, but like parts of that code is literally still there.
Yeah, the same for the NATs, the configuration format predating many of the, it was based on that Lexer from Rob Pike. The same one, yeah.
But don't tell this to Rob Pike, because he doesn't think it's production quality code. So those modifications are important.
Oh, wow.
Yeah, the one thing I learned from his talk is that Lexers that concurrency was actually invented for parsing source code. That was particularly interesting, and I also use it for my NLP libraries. So yeah, Arthur, what's your answer for the book?
I don't read. I don't have any Go book to suggest. I suggest you to visit the Canonical website. I learn the Go language from there, and follow the tutorial, and you will master Go. It's quite easy.
Emmanuel?
Yeah, honestly, I've also never read a Go book, but I highly recommend. The standard libraries documentation is usually good, and like I was saying, reduction of complexity comes from just focus on one thing you want to work on. If you need to do arithmetic, look at math or math/big. If you want to do networking, look at net and net HTTP. Isolate those, focus. But having said that, the Go book written by Brian Kernighan and Alan Donovan is one I'd recommend anything from Brian Kernighan. He was one of the authors of K&R, the C book, and that's quite the gem. Compact, straight to the point, teaches a whole lot. So we're lucky enough to have him work on a Go book. So I'd recommend that, even though I've never read it. Thank you.
Cool.
It says a lot about the simplicity of the language that most of us don't really feel the need for Go books.
Right. Yeah. Yep. So I've got the next question, but let me take a cup of coffee from my donut. So Emmanuel talked a lot about like the number of connected elements and their relationship, and when he said that in his talk, I immediately thought of Veronica's talk, which says, topology, because you can talk about the number of connected elements and the relationships, and hey, that's a simplicity of complex there, right? So the next question is to Veronica. If you can quickly tell us how you would formally verify distributed systems using algebraic topology.
Yeah, so it's very simple. And the concept, like, it comes from the idea that you can express any distributed system in terms of a graph, like a graph theory. But in modern distributed systems, that graph usually is super messy and huge, huge, huge. And like usually when I give talks about this, I put a slide where representing an actual distributed system, like the graph of it, and it's not helpful anymore because like graphs are meant to make our lives more useful, like visually, but also like for tracking the paths and all that. So what do you do once that graph is not helpful enough or it becomes messy enough? Well, you can do, for people not familiar with math, you can represent the same graph as a topological body, let's say, or as a topological figure, and it's equivalent, just like you can express anything as an equation, like in geometry and algebra, and it's exactly the same thing. Like a very similar thing happens there. So it's basically that, and like the way you verify it is, well, the proposal for this is to, if you are able to express your system in terms of a topological object and you're able to prove it like mathematically, like a normal mathematical proof, then your system is correct.
So you prove things like that it's simply shell or
yeah, you know, like the mathematical proof, like let's recall your calculus classes lessons, like back in high school, and how they made you prove things, you know, like prove that 1 + 1 is 2 and stuff like that. But it obviously sounds like magic because explaining it like this, it's very simple, but it's tricky because the trickiest part is obviously having someone on your team that is familiar with this concept and is able to like really translate the system accurately into mathematical terms. But once you have that done, the proposal is that you can prove your equation or set of topological entity equations as mathematical proofs. And with this, it's not just magic. It's like when you prove it mathematically, the thing is that you are proving all the interconnections, like that all the interconnections are valid, and yeah, all of the implications of every different system. So yeah, that's basically it.
Just a quick follow-up on that. Is there some tool to help you convert your distributed system into a model? Because just modeling a real-world system is itself like pretty hard problem, because you put all these small things which would behave in a certain way to deal with edge cases, and then it becomes so hard to like model that.
Yeah, I mean, I know different tools that I don't remember the name right now for, not for the whole thing, just to convert, let's say, any variable or any system into a graph, like a graph theory. Then I know other software such as that doesn't have anything to do with distributed systems, such as Mathematica or Wolfram and all that, where once you have your graph in terms of not visual, but like in terms of vertices and the others, edges. Thank you. In terms of vertices and edges, it can be converted into a topological body. Of course, something that would automatically convert everything, like how the sausage is made, would be a huge effort. But yes, maybe someday we will do it. But yeah, that's basically it in a nutshell. I know there are many questions, but yeah.
Well, that is with the assumption that the homotopies are preserved, which leads into the next question, right? Manish's questions leads into the next question, and it's going to be a group question. And instead of asking one by one to answer, just pop up with your answer right now, because I'm tired of going through the list and calling names. So what do you think is missing in Go right now that will help the community build better distributed systems?
Controversial takes.
Go on.
I think I would love to have a malloc and a free, so that it can introduce like manual memory management along with the automatic garbage collection. Like you don't want to get rid of the auto GC, but you do need manual memory management too, because if you look at obviously my talk and what we were seeing in dgraph, but then also look at Ed's talk from PingCap, memory management and GC, just time it takes, which is sort of like both correlated, right? The more memory you allocate in Go, the more time GC would take. That then eats into the performance of the software and so on and so forth. All of this originate from the fact that you have to do these sweeps. And so having a hybrid memory management model would actually be really great.
Anyone else?
Well, I will just comment that this does not sound very Go-like to do free and allow.
That's why it's a controversial take.
Yeah. I've needed some help from templating actually recently. I've run into some cases where it'd be kind of nice if I could use like a priority queue or something, and I have to like implement my own type specific priority queue, so generics, which is already on the way actually.
Yeah,
that would be cool. That might help, although I don't know, it's not like a huge need, but every now and then I do bump into like, oh man, like I wish I could just pull off a priority queue or a tree or something and just use it. So generics, I guess.
I mean, maybe it's a failure of imagination on my part, but I'm not sure that there's really something needed at the programming language level to improve the distributed system story. To me, it's more something that would be built on top of the language. I don't know if we would recognize Go if it changed to the point where it actually made distributed systems programming better. It would probably not be the same kind of programming language.
I've been quite partial to Peter Alvaro's ideas though, in terms of that. He's been taking away semantics and yeah. Anyway, Vicki or Wally or Arthur, Emmanuel, what's missing in Go right now?
I think. Oh, sorry. No, I think the whole chapter with modules is still not over, in my opinion. I think it's still in flux.
I agree.
I think there's still like something like next iteration that needs to. Right now, I'm actually very scared of the modules. Sometimes it's kind of like I've been beaten by it by quite a bit, and there's actually a proxy. There's a proxy, and to me, it's kind of like a basilisk. You know, that it fetches all your dependencies, and if you put a commit out there, it just fetches it, and then you break everyone's repos. So I think something, it's getting there, but I think maybe like something with Go modules, ready to Go modules, but really not sure what it is. Yeah.
I would like something like Okamo's module system, but that's asking too much, right?
For me, it would be some mechanism for fault tolerance. I know, as it has been mentioned, probably that would imply many things, not just in a technical level that is obvious, but like in terms of probably even changing like a spinal cord of the language. But I don't know, who knows? I know that some people who were involved in Erlang were recently-ish hired for the Go compiler. So probably for Go 2.0, we'll have something like that, but I don't know. That I would really love that.
Imagine Go routines that can panic, but the panic do not propagate to the main program.
Yeah, that would be my dream come true.
Anyone else wants to chime in, Emmanuel?
I'll let Vicki, did you want to answer?
Oh, I was just going to say, I think echoing what Nick was saying, I don't have any super bright ideas for the language itself, but I feel like there are always exciting things coming out of the community, like, packages and services that are being built in Go. I think recently I saw that Cockroach Labs did a rewrite of RocksDB or like a partial rewrite of RocksDB in Go. So they got rid of like a CGO barrier that they were using. So I'm excited about those kinds of things, but maybe I just need to give this more thought.
Yeah. Right. So Emmanuel?
Yeah. So firstly, I'll answer Jamie's question. Hey, Jamie, if you right now go to golang.org/pkg/container, you will find some Christmas is a Christmas gift for you there. So
yeah, I found that package, but that uses like interfaces, right, for everything.
Well, so it's pretty much like using Reflect, right? You implement in order to implement like a heap, you need comparators and things, right? So yeah, I mean, you're right. We need generics, but these packages could solve your problems. And in fact, we even have a circular ring buffer.
Yeah, I've checked some of that stuff out.
Yeah, and then in regards to things that I'd like to see for Go, one that's highly neglected is, so right now there's pprof, right? But pprof is so difficult to use for most programmers. Like, very few people profile their code, and most of the times when people do engineering cycles of what needs to be fixed, all these things, no one knows exactly what's going wrong. 2 weeks ago, I audited some code, and I found they had added like custom regex-based validation. But one problem was that they were returning regexes, brand new regexes, function. So what that meant was that every single time they needed to parse just a really simple, 4-letter sequence, they were allocating about 1.2 megabytes. Imagine it every single time. Right, so I filed a bug, and it was the name of the bug was "Death by 1,000 coins." Right, every time they parse one, if they parsed 1,000, they'd run out of RAM. And there are many things like you'll see people use strings.index or versus a different variant, or there'll be like crazy byte allocations, but no one actually knows what's going on. And when people need to profile, they'll just grab out a toy program, don't know how to interpret profile. So I wish we had continuous profiling infrastructure. Then also one of the things that I'm actually working on is static analyzers. Like there's so much invalid code that's out there that is very on my Twitter profile. We've been posting analyzers we've been writing, and like they're very shocking. Even within the Go project, you'll find like, for example, there's a mistake that is common, whereby to accept a signal with signal to notify, you're supposed to pass in a channel that's buffered. We found, even in the Go project, we found this mistake. And in examples which were written by the authors of the Go project, there were these mistakes. We found in hundreds of repos. So that, then also things like HTTP errors. I also think the HTTP package could be designed a little bit differently. It's amazing to use, but when you get to like the 95th percentile of cases, it gets a bit tricky, and you have to, develop deep finesse. So those are some of the things I think could be improved.
Cool, Arthur. And also the next question will be for you, but before that we have ad break, because I have to give a shout out to our sponsor, which I actually forgot to give. Fauna is actually the data API for modern applications, and they're our gold sponsor. So if anyone who is watching, if you want to have a data API, check out www.fauna.com, fauna.com. And now back to Arthur.
Okay. I'm quite satisfied with Go. You have mentioned, many of us have mentioned some features, and for example, the module, genetic, and the package management. But I think the Go team has done a great job and improving Go. I come from the C background, and I think writing Go code make my life much happier. And Manish mentioned that he want the alloc and free interface. I don't think it will make our work better, because I don't want to go back to the age that we manually control the memory. The Gabi recycle has done a great job for us. I really like that. Although it has some pitfalls, we can chew them. Yeah. In a word, I think I am quite satisfied with Go.
I see. Okay. Our next question is actually for you still, and it's by Manish. So Manish, you can
actually. I would like to ask. I think so. One of the things that Ed had mentioned in his talk was that you guys are using CPU pinning, and I think there's a term for it, which I'm not. I'm forgetting what the term was. Do you remember what the exact term was that they were using?
NUMA, CPU pinning for NUMA.
Yeah. So how does that work? Like, are you forking TiDB into 64? If there's 64 cores, into 64 sub processes, and each process is tied to a CPU? How does that work?
We can avoid the NUMA problem by set up a multi TiDB instance. So and then we bound the NUMA core to the process. So we can get rid of this problem by using this way. Yeah.
So on a single processor, there are NUMA cores and non-NUMA cores. I ran into this issue for my machine learning library, and I gave up because it was very difficult to figure out whether you are currently running on a NUMA core or not.
Yes, that's very. We can't solve this problem from the Go runtime. We can avoid this problem. We can start a manually Go process and then have a proxy in front of our service. So we bound the NUMA cores for each process to avoid this problem.
Cool. Okay. Anyone wants to jump in on NUMA, because it's been giving all of us a lot of headaches, I guess. Is it a good thing, Daniel?
Well, I've got no experience with NUMA and Go, so I didn't quite get Arthur's answer, and it's definitely a good thing. But I'd really like to learn more about how people deal with it in Go.
Okay, cool. Because to give you the rundown is that Go's runtime is not NUMA aware, so it may allocate memory from a wrong core out of your normal core, and there you got a lot of jumps and movements. But yeah.
So what do you do, Arthur? Do you have like different processes and that run on different cores, or?
Yes, I think the NUMA is something related to the system. We know if we are user of Go, we maybe we need to know some knowledge about the Go runtime. But if we are writing code, we need to if we want to tune the system, we may need to know something about the system also. So this problem is not something a user needs to solve. It's the Go team may solve this problem or improve it. But if you want every programmer to know a lot of the system and tuning the system, I think it's quite difficult for every programmer.
Okay, cool.
Can I have a follow-up question? Not follow-up, actually, a different question to Daniel. We are looking into introducing roaring bitmaps to the DRAF code base, and actually it baffles me that we didn't do it already, 3 years ago. Is roaring bitmaps also sort of SIMD optimized, the Go version of it? And what's your journey with SIMD? It seems like you use SIMD pretty extensively.
So so for people who don't know, right, rolling bitmaps are kind of an indexing data structure. It's kind of a set data structure. Yes, we do have some fancy assembly that that can go itself. Of course, I don't think as an auto vectorizer that can generally be good with SIMD instructions. So these wide instructions that are very fast. We do have some assembly. We also have a version that is a wrapper around the C library. And there, in theory, you could compile it. Now, by default, it's not, well, it's going to be compiled with some SIMD support, but you could tweak it. But then, of course, then you have the problem that we know, the general problem that interfacing Go with C is it does not come without cost, right? So there's a barrier there that can be a problem. But yeah, there is some limited SIMD support.
Cool.
I think, and the second part of the question was how do you get started with SIMD? Because I think like fast JSON, rolling bitmap, and in general, like a lot of the work that you have done with even with the variant sort of encoding and stuff like that, it seems pretty inspired by SIMD.
Right. So the general idea. So it's a general question that all of us are a little bit aware of. So there was a question about which book you've been reading, and we all know, like, when you get to a certain level, basically the books are not so helpful because there's a lot. There's actually a massive amount of knowledge that's not very well documented anywhere. It's all parts and pieces that you have to kind of explore a little bit on your own and figure out over time. So there's actually precious little documentation, and it's basically a massive amount of trial and error and reading undocumented code and trying to figure it out. So I'm sorry if it's not a very helpful answer, but I think all of us who are a little bit experienced can probably what I'm saying hopefully resonate a little bit with you. Like, you just try to figure it out. You just try again and again until it works. I would say something that's related to that, and it's related to what Emmanuel was saying. One thing that I find is really great in Go, and it's part of the design, is that it makes benchmarking functions really, really easy. And not all programming languages do that. And that's a really, really useful feature for people who want to explore, performance issues, is that you can get started right away. If you compare with something like, I don't know, Java, benchmarking a function in Java is, it's hard. It's much, much harder. It's like 10 times harder. So this makes a big difference. So, like, to be good at performance, you have to be measuring and measuring and measuring all the time.
Can I also jump in here with Agnifog? If you want to know more about SIMD and instructions, Agnifog is pretty much the best resource I know of, besides Daniel's blog, obviously. And yes. Also, Bruce Dawson, Daniel, Agnifog. These are pretty good resources. Daniel's blog is amazing, by the way. Everyone should check it out.
Yeah. So he has great optimization manuals, and he's been doing a lot of work, and you've got, frankly, another resource that you didn't mention is just Twitter, because this secret cabal of people who hang around and have all of these crazy discussions that are very, very focused, but you're never going to see that on a blog or very rarely on a blog or in a book, right? So Twitter, for example, is a great resource.
Cool. Yeah, I agree with that. And speaking of Agnifog, do you guys know that he's actually an anthropologist? Because that's surprising. And speaking of anthropology, throughout this entire conference, there's been many like discussions of what essentially are impedance mismatches between a single computer, a single guy sitting in a computer and doing his stuff. For example, Nick was talking about testing, right? It works on his computer. It takes a long time on his computer, but on a CI, it just takes seconds to run. So there's generally an impedance mismatch between a single human and distributed system. So what can be done? This is a group question. What can be done to sort of close that gap, you know, between the doing things in one computer and distributed systems?
So the question is, how do you design a program to make it so that it can run on a distributed system?
I think, no, this is more cultural, right? So Verónica and Anna talked about embracing failures and designing fault tolerance. How do you, that is basically an impedance mismatch between a person sitting in front of a computer, a local function and a distributed function.
Yeah, I was trying to ask if the question was more like social or like
it is social.
The culture of your teams and stuff like that.
Yeah.
Well, since I already have the microphone, I would say that, yeah, definitely, in my opinion, experience building a distributed system is always best, or most of the time best, when it has a lot of people or more than one people or more than two people building it, because first of all, for technical, very deep technical reasons, like there are so many interconnections that you might not be seeing and just someone else might see them, and that replicates, you know, the more the merrier, with some limitations, but you know what I mean. Then the second would be also like to have pristine and very effective practices and how you push your code. It might sound super basic or even a bit dumb, but when you're building a distributed system, it really, really matters, like the consistency. And I'm not even talking like at the database level or stuff like that, but like consistency of the thought of like what we are trying to build together, to have things very clearly outlined. And that's what I mentioned in my talk, like that I think that for distributed systems and concurrent systems, it really, really matters how much you plan. I think that most of the heavy work happens in the planning, and the implementation is, I mean, just the implementation, as opposed to other areas of computing where you can experiment more, like directly in coding. So yeah, probably even if you're distributed like as a team, or that you're working at different times, different time zones, different environments, and asynchronous, just having a very outlined plan of what are you going to do is the way to go. I know it sounds very simple, but achieving it is very hard.
And in much irony, you're introducing a single point of failure. If you accidentally delete that Google Doc, oops.
That's true. That's true.
Anyone else wants to chime in on how to fix the culture when it comes to having the impedance mismatch between individuals and distributed systems?
Yeah, I can kind of, actually, one of the things that Veronica said about communication, I think that's definitely something I've noticed is it's kind of pretty hard to get right. A lot of times when you're working with someone, maybe you have an idea in your head of, you know, how you want the system to work, but you might not be able to, you know, describe it correctly, I guess. I found like drawing diagrams, whiteboarding and stuff like that helps like just convey an idea a lot easier sometimes than like Slack messages or emails. And oftentimes I think once you nail down the communication, then it's kind of like how Veronica said, it's just the implementation. That's kind of like the easy part once you know what to do, but like figuring out, agreeing what the design is, what the interfaces are going to be, what guarantees they have, and all the contracts and stuff like that. That's like super important. I think maybe that might even be like the hardest thing of engineering in general, right? Like coordinating with other people.
The social bits of engineering is quite definitely quite hard. Yeah, anyone else wants to chime in?
Actually, like one thing I've noticed about as you're building a distributed system, you realize that you don't actually have a lot of guarantees, right? And that's the first thing that I realized, like, the engineers at DGraph, we have to teach them is that it's not, if you're running on just one machine, then you get mutex locks, right? And mutex locks are definitive, right? You have access serially. In a distributed system, you don't have, like, if you're going across the machine boundary and doing network calls, there is no guarantee about whether you'll actually be able to make that call, whether two calls will be done at the same time, whether the call that you sent first would be received later, right? So there is no guarantee about the ordering or in the way in which they would get executed. And that breaks a lot of assumptions that engineers tend to make. And that's why distributed systems get harder. And so that's the giving up on all those assumptions is like sort of like a mental shift that you need to sort of like kind of learn or unlearn depending upon wherever you're coming from.
Yeah, which kind of goes back to the communication thing, right? Like if you don't specify like, hey, we don't have any guarantees, hey, you have to retry things. If you don't say that, someone might kind of assume that, hey, you have to grab the lock here, or hey, actually don't grab the lock here. This already grabs the lock. You're going to cause a deadlock if you try to do it again, right? So getting all that out and communicating it with your team is super important. Yeah.
Personally, I have my opinion about that is I think one way to bridge that gap is pure sensationalism. As odd as it sounds, I'll explain. Do you remember the fad of MapReduce?
Yes.
Just the entire
world.
Yeah,
it was like, it died down. Who talks about MapReduce now?
Or Hadoop.
Right, exactly, right.
That was developers.
Right. So it seemed back then that to be accepted in even social circles, somehow you had to pretend to know about MapReduce. But what that did was that it actually brought distributed systems into thinking a lot, right? Like all of a sudden now people were thinking in terms of, hey, you know what, just write mappers, write reducers, simply separate out your code, microservices, right? In fact, I'd argue that we tended towards microservices just based off such history. But on top of that, to sort of reply to Manish's question, I think trying to make paradigm shifts with most engineers or pretty much everyone, like human society, it's a very hard thing to convince people that the way that we're doing things, which is very simple, it pays their bills. If it ain't broke, don't fix it, that kind of mentality. I think what we need to do are get core folks to build really good distributed systems libraries, like build a lock server, right? And represent that in libraries that we use as a mutex lock. So you say, hey, look, I'm locking for this resource, right? Developers on their end, when they're writing the code, they'll be like, yeah, you know what, I'm locking this resource, but it could be retrieved from a lock server. Add things like exponential backoff into the libraries they use. Like the number of times I've had to fix bugs that came from like exponential backoff, whereby people like implement lockstep backoff, whereby they don't introduce any into their service. So all of a sudden, everything fails at the exact same time, tries to back off at the exact same time. So I think simplification.
And thundering hordes happen.
What's that?
Thundering hordes.
Exactly, thundering hordes. So I think conceptually what we need are that sensationalism. We need to get core folks who understand these things to build simple abstractions, roll out nice libraries, roll out infrastructure, and then do mass marketing. You're like, hey, look, all of a sudden our small app went from making 10,000 sales to 100, 1 million of them, and this is how we did it. We use this library. You get Daniel is a professor of CS. Daniel can help with this propaganda. Tell our students about tell most students about these things. And by the time they go into the industry, they already have this at the top of their heads. So that's what I think could help.
Cool. All right. I think we're running out of time, so we have one more question, which was originally for Vicki, but it can be for everyone. So what about memory consumption in long-running Go routines and garbage collection? Let's say we have a long-running Go routine as part of a server, the allocation of the memory grows, and assuming that there are no leaks, what are the best practices to have from growing infinitely? It's open to everyone as well. But Vicki, go.
Yeah, that's a great question. I mean, I think garbage collection and Go routines comes up a lot, and it's something that I didn't go into since I think you could talk for a long time about the Go garbage collector, but something that I'm sure a lot of you know is that if you manually invoke garbage collection, all Go routines have to be in a stopped execution state before the garbage collector can run. So if that's something that you're thinking about doing, I would just keep that in mind in terms of what it might mean for your program's performance. And in terms of long-running Go routines, I think one of the things that was a really key design consideration in the switch from the previous way in which the Go routine stacks would shrink and grow into the current method of like stack copying is that now, at least when we're talking about like memory on the Go routine stack, since we allocate a new chunk from the heap that's double the size of what you need, if your stack shrinks after that point, that memory is sort of naturally freed back up. So you don't have to deal with some of the same memory problems that came up before. So I think that was a nice feature in terms of that shift. I can't remember which Go version it happened in, but I think that was one of the main considerations. I don't know if other folks have more detail to add, I'm sure.
Quite sure everyone would have some opinions on that. Nick, any opinions?
Nothing that I can really say succinctly, I think. I will note that I had discovered after my talk that part of the reason why I was having so many memory issues is that I did have some memory leaks involving long-running Go routines that I was failing to stop. So not just in my tests, but in the actual code, there was an undiagnosed, undiscovered memory leak relating at least partially to Go routines that weren't properly terminated. So sometimes the problem is not just that you have a long-running Go routine, but you may have other long-running Go routines that you weren't aware of because you weren't doing like a Go routine leak detection or something like that. So that's my one takeaway is monitor your Go routines.
There's one thing that we had identified is there's Go routine leaks and there's memory leaks, but they could also be, I don't know, should I call them CPU leaks? Because if you have tickers which you did not stop, they will continue to like use the CPU cycles because you just forgot to stop them. And even if they go out of scope or something, like they'll continue to keep up the CPU occupied. And we learned that the hard way in dgraph like 2, 3, I think maybe three years ago. So that's also something to be aware of.
Okay. Last comments and we'll shut down. Sorry, this is pretty late, so we should have a last comment. Anyone? No? All right. Well, thank you for being here. Thank you for participating in this Q&A. Your talks were amazing. I learned so much from each and every one of you. So thank you for being here. And that's a wrap for Go Systems Conf 2020. Thanks to our sponsor, Fauna. If you need a data API for your application, please check out fauna.com. Thank you, everyone. See you next year.